I started recording, and today we are going to talk about movement. And in Unity, there are really different kinds of movements. Uh, there's a use for each different case, each different method. And I mean, my goal is to make you really uh, knowledgeable and uh, basically a master in movement, just like we did in our last lecture about rigid bodies and collisions triggers. So we will again see a huge range of methods, and we will talk about the uses of each. Uh, so my reference for this lecture is these two YouTube videos. Um, if you want to access, quickly, you can check those videos out. As you see, it's a long video, around 50 minutes. I left a link in the WhatsApp group, and yeah, I guess we can start. Okay. First things first. Let's talk about um, moving cubes in. I mean, moving our objects inside editor. There are some cool tricks that you can use. Okay, so first of all, when this tab is selected, you can drag the arrows and move the objects. And also, if you click the plane, there are 3 different planes for each combination of dimensions. You can also drag this cube in a plane without changing its height. And if you want to access this tab, you can if you have clicked in another tab, you can click W and it will make you jump to this tab, and now arrows appear, and you can, like I said, drag them however you want. And also you should notice that these arrows has colors. So blue stands for Z direction, red stands for X direction, and green stands for Y direction. And you will notice that it's different from world coordinates, and this is because local coordinates may differ from world coordinates, especially if you, for instance, rotate this object. You will see how local coordinates are adjusted, but not world coordinates. So just keep that in mind. This will become important when we are giving when we are creating a movement in a certain direction, because if we use world coordinates Z, then it will move in this direction, so it will move downwards kind of, but if you use local Z coordinates, and if you move this object in this way, then it will be going right. Okay, another trick that you should, I mean, you could use inside Unity editor is snapping. If you click this object and drag it while holding shift, it will be snapping perfectly. So if you, let me just click this. Yeah, now we're controlling first cube. So if you see this positions, you will see that actually, let's get rid of this part. Let's make it 4. And let's make this 3.5. Okay. So if I control click and drag, you will see that my Z position is getting updated 0.25 by 0.25. And now I can, control it quite easily. And also, another trick that you can use is snapping to another object. You can do that by clicking Command Shift and yeah. Let me just, for instance, I guess it's snapped. It snapped two cubes face to face, as you see. And if I use Control V, Control Shift V, I guess. Let me just, there's a way to snap by vertices. Vertices are edges. So I tried to, oh, okay. Yeah, I now noticed. If you click just V, then it will snap by vertices. So let's check that out. Since there's a plane, it's messing with us. I'm going to disable the plane just for now. And also I'm going to disable directional light too. So if I click cube 1 now and I click V, it should be snapping. But yeah, I should use, for some reason, I couldn't snap by vertices. So let me check this shortcut real quickly. I guess it changed. Unity vertex snap. Oh, okay. Yeah, I guess you should select this vertex before trying to drag it. But yeah, I guess I couldn't properly do what I was trying to do. So I will try this during the break. Actually, it's doing what it should. Yeah, exactly. So by vertex, it means corners. So this is my misunderstanding. So if you click to a corner and click the V button. For instance, if you are near a corner, when you click V button, it will automatically let you drag from this corner. And as you see, when I move my mouse, it's joining two different corners of two different objects. So this is a cool trick. If you are having a game like Minecraft, which you are using a lot of blocks, or if you are having a platformer like Super Mario, this could become quite useful. So I'm going to Control Z a couple of times so that my plane is back and also my cube is adjusted like this. Okay. So these are the different tricks and shortcuts that you could use while arranging objects in your scene. Now let's talk about how you can move objects within the script. So in this scene, I have 5 cubes, and each cube has a different movement script attached to it. For instance, cube 1 has set transform position script. I mean, those 5 scripts are written by me. Transform translate script, rigid body add force script, rigid body move position script, and rigid body set velocity are all added by me. They are not Unity scripts or Unity components. And I have one other object which I called barrier, which should stop my other objects from moving since it has a box collider. Okay, so let's see what is going on in action. Okay, so 5 objects are moving in different paces, and their movement is also quite different. So let's go over them one by one. Okay, so our first cube is using set transform position script, which is a quite popular way to move objects. It is accessing the transform.position of the object that this script is added on, and it is increasing this number by this much. So transform.forward is the vector representing the blue axis of the transform in world space. So if we go back, this blue arrow is pointing towards right. So now we can safely say that we are transforming, I mean, we are positioning this object towards right. But I mean, according to the object, it's going forward, you know. And we are multiplying this value by time.delta time. By the way, this will return a normalized vector, meaning that it's, if you remember from your physics lectures, a normalized vector is a vector which has the size 1. So this will return a vector like this. So it will be 1, 0, 0. So its x value will be 1. Both y and z value will be 0. So this is equal to this 3-dimensional vector. And we are multiplying this by time.delta time, because if we did not do that, with each frame update, we would be moving our object by 1 in the x-axis. and this is too much. This is too quick. We want to multiply this by a small number, and this small number is time dot delta time, and this represents the completion time in seconds since the last frame. So it will be something like for instance 0.02 seconds. And if since we are multiplying this small number with that, we will have a quite small number, and because of that, we will be moving pretty smoothly and independent of our frame rate. So it won't be affected by our machine's performance, and it, as you noticed, it will be adding. Sorry, it will be. Yeah, actually, it will be adding a, you know, um, similar amount with each frame, and we are actually kind of normalizing um, this frame speed or FPS by using this. So we should get a smooth transaction. So to an uneducated eye, it should be moving in the same speed. As you see, it's moving in the same speed. Sometimes we are adding more, sometimes we are adding less because we are multiplying by time dot delta time. But when we take the um, amount that this update method gets called, also differs. This and this cancel out each other, and we can say that we are going forwards about 1 each second. Any questions? So we started with something quite basic. Let's go with the other methods, which is also using transform. By the way, our first our first two cubes has no rigid body component inside them. And if you don't plan to use physics related stuff, or if you need rigid body for some collisions, but if you prefer to move objects as you want, you can change its position directly with transform.position, as in our first two examples. So now we will be covering another transform related modification, which will be our transform translate script, and it translates our transform by this amount. So it's basically the same thing. I prefer this one since it looks nicer, but you can also use this. It's also using arithmetics, and it's not hard to understand. These are basically doing the same thing. Translate means ötelemek in Turkish. So you are you are teleporting this object by a certain amount each frame. So by certain amounts, I mean the calculate the result of this part, you know. So translate moves the transform in the direction and distance of translation. And also in this vector, you can, you know, add another parameter. Um, so if you add space parameter, you can move the transform object. Yeah, I mean, you can move the object in the direction and distance of translation. So you can use space.self or you can use space.world. If you use space.world, this applies transformation relative to the world coordinate system. So you can try those out, but for our case, this is, I mean, pretty useful already. So since we are doing the same thing, they are moving at the same speed, you know, and you know, they are not being stopped by our barrier because they don't have rigid body components attached to them. I could actually add, just for fun, to show you that adding a rigid body will make them stop, since it will create a collider, it will create a collision, just like we talked in our last lecture. So, I mean, I'm an advocate of rigid body based movements in general, but for some certain cases, this could solve your issue. By the way, you should notice that uh, our rigid body movements have stopped, but our uh, transform translates based movements are not stopping, because each frame they are trying to teleport themselves a little inside this barrier, okay, and unity collision system notices that, and you know, tries to move them back. So since we are not using uh, physics based calculations, and this is I mean, this should be expected, and we get this weird vibrations, unfortunately. So this is the problem with using transform.translate or setting transform, basically. And if we, I mean, our last three examples will be using rigid bodies, and we in each example, if I click each script, so rigid body add force, rigid body move position, and rigid body set velocity are the three scripts that I will be using for each different cube. So within each script, I have a force multiplier. We will get to that in a second. And we have a rigid body, uh, which we, uh, you know, which we get access in our awake function. So by using get components function, we are able to access the first rigid body component that we uh, solve inside our object. So since we have access to our rigid body object from the get-go, we can do some things to that rigid body inside our update function, and we do different things inside our update function in each different script. For instance, in that case, I'm not using force multiplier, so I'm going to delete that for easier understanding. And in these two, I'm using force multiplier. Now let's talk about rigid body add force. This is similar to what we have used in our sample game. If you remember, we added force to this object in each frame, so it was able to go forward. And inside our update function, we are taking its forward direction. So again, this will return a normalized vector representing the blue axis. So we are talking about local x-axis, and it will be multiplying this by our force multiplier. This is just a variable for us to change our force without changing this line of code. We can just change this force multiplier to 400, for instance, and our added force will be doubled, basically. You can even access this number within the editor and override this variable. So if you change this variable from the editor, it will not care about what is written here, but it will use the variable inside the editor. This is just a default value. If you haven't specified what you want to use inside the editor, Unity will use this number. And again, we are multiplying this result with time.delta time. Since we are calling this line inside updates and we want to be independent of our frame rate or FPS. So this will give a net result of this. So if you see the third cube, this one, um, this one is this one has the rigid body add force script attached to it. So if we play it one more time, you will see that it gets some acceleration. It gets velocity, and if there wasn't a barrier here, it would increase its speed every frame, since we are adding force to that object in each frame. So it will go after some time, it will reach to speed limits, uh, speed of light, and another I mean, by the way, if you have any questions about this, you can say those. So okay, in our next script, we are using move position, rigid body move position, to move our rigid body, and in within each update, we are calculating the new position, and we are calculating this position by its already existing position and uh, how much we want to move, and we are setting rigid body's new position by this vector. So it will move, it will be teleported to this location. So rigid body will be teleported to this location. This is in practice quite similar to set transform position or transform translate. So the difference is this cares about rigid body. So I believe it's more suitable for physics related games. If you are caring about, I mean, you are either um, moving all of your objects by its pivot point, or you are trying to move its rigid body, and your object follows your rigid body. So if you want to, get uh, notifications about collisions, this could be more performant, I guess. But in practice, like I said, they're pretty similar. Um, so any questions about this? I'm going to plug in my charge cable. So okay, um, since this is using move position, by the way, it will be having a constant speed. This guy is uh, making itself. I mean, this guy is trying to make itself teleport inside the barrier. Uh, so it's like in the first two cube. This is also trying to uh, go inside, teleport inside this barrier. But uh, since Unity detects collisions and avoids, I mean, at least tries to avoid uh, objects from going through each other, there's this vibration effect. But since our physics engine gets called more times, uh, you know, fixed update and stuff like that. I mean, if you are using rigid bodies, then you will. Uh, I mean, basically, we are calling update in both cases, in all of our cases. But since Unity will give better results when you are using rigid bodies, this vibration effect is not that bad, so in our first cube, it's like this. It's really annoys players, but in our rigid body case, it has against some uh, vibration, but it's not that bad. So I mean, using rigid bodies basically give better results, but of course, since you are adding some physics calculations, it will be less performance for your machine. And our last method of moving is rigid body. I mean, is using rigid body again. So if I open this one, you will see that I am setting um, some velocity to my rigid body uh, with inside my awake function. So in our four cases, we moved inside update. By the way, uh, actually, since we are dealing with physics related stuff and rigid bodies, maybe it's better to use fixed update here, and let's get rid of this comment line. And let's see our fourth cube. So let's see how it will move. So since fixed updates gets called um, in the same rate independent of the performance, um, our vibrations are even better. We cannot even notice if it's vibrating or not. So just keep that in mind. And in our last case, by the way, in this example too, I want to use fixed updates. So it will be adding some force, and it will be called with each frame render, not frame render, but with each physics engine tick. And in our last case, I'm setting the velocity of my object inside my awake methods. So when this object gets initialized, or the scene starts, my game starts, it will have a speed that I calculated. And this, I mean, since it will have a constant speed, it will try to move each frame. So if I focus on my last cube, it's hitting the barrier and it is bouncing back. The bouncing is, because it has a rigid body component, and I actually disabled its use gravity function, because if I use gravity for my fifth cube, it will be stopped rather quickly, since there's some friction between uh, my floor and this cube. So it will be slowed down quite easily, just like this. I mean, there are ways to mitigate that. You could add a physics material to that, so that it will have zero friction, or you can uh, change the drag and angular drag to lower the friction. I mean, right now it's zero, but for some reason it's still having some friction between floor and this cube. So I just unchecked use gravity, and because of that, it's actually floating. As you see, my objects are not using gravity and they're floating. And since it's not using gravity, after the collision, it's jumping. I mean, it's going upwards. Any questions in that? So again, I mean, maybe I shouldn't use time.delta time. Let's see what happens if I don't use time.delta time. Let's see if it will be too quick for us or not. Yeah. So yeah, if I don't use time.delta time, it will basically be too quick for us to even see. So let me just focus on this object, and it will be, too quick, and it will be even not. I mean, since it's too quick, if you noticed, it got past this barrier. Our collision detection was not able to work properly, since it's too fast. Uh, I mean, my physics engine could not calculate if it went from here to here. Uh, so it didn't capture the collision. So now this is why I'm going to reduce its speed by multiplying this velocity by time.delta. Okay, any questions in that? Good. So I guess we can um, go to our next methods. I mean, those are the 5 common methods that you could use. So this is why I wanted to give them together. But now we will talk about moving with inputs. We will talk about translate rigid body one by one. Um, so this was like a summary of all the things that we will see, uh, and this should act like a recap basically. Now we are going into the actual stuff. So first, I'm going to open this folder um, called move with input, and I'm going to open my other scene, which will be box moving with input. And in this scene, there are some scripts added to my moving box, and if you notice, only one of them are checked. Other three scripts are disabled, and all of those scripts are using move transform. So we talked about moving with transform, but now we will see the depths of this. And let's start. So before delving into the depths of those scripts, I want to actually show you something. Um, since we are going to be moving our object with some input, we will basically capture uh, some events, some input events created by our user. For instance, if our user clicked left arrow button, we will move our uh, object to left, etc. And to deal with those inputs, there's a menu in Unity. I'm going to actually search for this menu since I don't remember the exact location of it. It will be called inputs, input menu. Um, so just tell me if you see input menu. Was it on inside project settings? Oh yes. Okay. So if you go to um, so how did I find this? So inside project settings, uh, you can go um, click input manager tab, and if you open up the access drop down box, there are a lot of different controls. Oops. So it's here, and there are some um, basic names for some buttons. You can also add some new names, but for now we won't be using that. So for our horizontal and vertical movements, there are pre-declared values. For instance, this rows says that if I click my left arrow button, my horizontal movements will be reduced. So I will move negatively in horizontal axis. And if I click the right arrow, then my movements will be in positive direction, just like in a game, you know. And I can You know, I have some alternative negative buttons. This is for some first person games. If you want to use WASD, you can use them. So those are default values. I mean, you can obviously change something like that if you want. And also, if we see the vertical drop-down box, our negative button will be down, up, and also WS. So, and it accepts both key and mouse button. So our horizontal and vertical drop-down boxes, as you see, accepts key or mouse button. So it's for PC players. But there's also one more horizontal and vertical here, which will be accepting joystick access. So, you know, as you know, Unity can create games for other platforms. So you can also choose to have declared both the um, PlayStation or Nintendo Wii controls and PC controls at the same time. So your projects can declare different controls for different platforms at the same time. We haven't used this in our example game. Actually, this is better for a couple of reasons. If you use, for instance, if you reference this part, if your user decides to change to use another key instead of A, then since you have referenced this part in your code, it will be updated automatically. But we did something bad in our game. I'm going to actually show you. So I'm going to open up the example project, and I'm going to show you why our example input system is bad. So this was our project, and inside our player, we had a player movement script, and it was taking, A and D buttons, keys, and it was acting according to that. But we should actually not we should not be checking A directly. We should instead be checking, like I said, this this horizontal control keys. So an example will make this clearer, as I believe. So let's go to an example. So let's see our bad example. So in our bad example, I am referring my key by name, and I have to use a string to declare this. And this method returns true while the user holds down the named key, in our case A, identified by name. So yeah. And let's see our better script. So now I'm going to show you the better example. So if I click moving box, I'm going to click to our first script, which will be move transform position with input. Yeah, so it's this one. So now instead of writing A, I am referring to my key code dot right arrow. So let's see what Unity understands when I want to access right arrow. I'm trying to. So it's Unity is holding a key code for each arrow, and this is a better way to hold. I mean, I can even differentiate between big capital letters, etc. So now uh, let's delve into the actual code. So get key down returns true during the frame the user starts pressing down the key identified by the key code in a parameter. Um, so if I click right arrow, this will return true, and immediately this line will work, and this line will move my transform dot position by vector3 dot right. Similarly, if I click left arrow, my position will be adjusted a little bit left. If I click up, it will be adjusted a little bit forward. And if I click down arrow, it will be adjusted a little bit backwards. And if I click space, my position will be set to this vector. So wherever, I mean, it doesn't matter where I am, since uh, this is not a plus equals, this is just an equal sign. I will be teleported to the same location. I will be teleported to base, as you can say. So I'm going to play this game, and I'm going to um, click right, and as you see, I have teleported, and I go forward and backwards, and I'm going to click space, and as you see, it's teleported me to the location that I have specified in my code. And as you can see, I can even pass through other objects. Since I don't have a rigid body, as far as I know. Let's check that. Yeah, I don't have a rigid body. I don't need a rigid body, actually, in our case, since I'm using transform. And because of that, I am able to pass through objects, and I am able to uh, you know move my objects by the same amount of uh, distance. Any questions? This is useful in games where you want to uh, where you want to move your objects by a certain amount. For instance, in games like Farmville, I don't know, maybe in Minecraft or stuff like that, you can snap your objects like this. So if there are no questions, I'm going to get to the next part. I'm going to disable this script, and I'm going to um, enable this one. So this is adding something to the previous script. If I double click it, you can see that I have declared a move speed vector, and now my aim is to move my object smoothly, so because of that, inside our update methods, I'm going to use time.delta time, obviously. So smoothly should make you think about time.delta time automatically. Similarly, I'm checking right arrow, left arrow, up and down arrow, and also I'm checking my space button. So again, my space button will teleport me back to base, and other methods, other lines of codes will move my position uh, slightly right, left, slightly up, or slightly down. Um, so let's compare those two. This was moving by vector3 dot forward. Now I am uh, modifying it by speed and time dot delta time. So because of that, since this gets called every update, uh, I mean, this uh, this line of code will be called, around 50 or 100 times a second, and it will be moving my object a really small amount of time each time, each frame update. And because of that, we will see a smooth transaction. And also you need to keep something in mind. This uses get key down, and this uses get key. So get key is a different method which returns true while the user holds down the key identified by the key code in parameter. So um, when I click right arrow, this will return true in one frame. But if I click and hold right arrow, this input.getKey method will return true each frame. So it returns true while the user holds down the key. And because of that, I will get a smoother translation. And as you see, I'm holding down left, I'm holding down forwards, up arrow, down arrow, and if I click space, now it's so it gets key space, and I'm going to try something. I'm going to you know go forwards, and I'm going to hold down space. So actually it just doesn't move. I'm holding down space and forward arrow at the same time, and nothing happens. If I remove my hands from the space button, now it goes forward, and now I stopped going forward altogether. Um, any questions in that? So you should know that when to use get key and when you should use space. When you should use get key down. If you want to capture just the click events, for instance, in jump mechanics, you should use get key down. If you are creating a racing game, I mean, sometimes get key can be more useful. Okay. I'm going to check the recording, and uh, now I'm going to uncheck this script and check the move transform position with input limit movements. So what this will do is to clamp my object it will create invisible barriers. And now I'm clicking upwards, but I mean, I can't get past this invisible barrier. And similarly, I can't get past this invisible barrier on the right. So there's an invisible barrier created by the code. So in our scene, nothing is happening, but I can't go to the left more, I can't go top more, and if I go here, I cannot go to right more than this. So how we do this? We do this by checking our position. So if we compare this with that, you will see that there's an additional condition added by double ampersands. And now when I click right arrow and my transform position dot x is smaller than 5, I am able to go right. If I'm not, so if my x value is equal to 5 or bigger than 5, I'm not able to go right anymore. So this is a nice way to clamp. Any questions? So this is quite similar to my previous example. Okay, so let's try something else. I'm going to disable this and enable this. So this is move transform position with input smoothly and rotation. So now this has both movements and rotation. So this will be looking kind of like a real playing character. So if I go, I mean, if I use WASD, it will be, moving like this. And if I want to turn, by the way, it has no limit, so I can go like this. And if I want to turn, I can click the E key. And if I want to turn to the left, I can use Q. So I am using Q and E to turn. And now if I click back, my local backwards position will be taken into account. So now it's like a parking game. So I am able to turn and go forwards at the same time. So it creates an effect like this. Yeah. So WASD, Q and E, and WASD. Okay. So let's see how we achieve this. This could be really useful in your games. So I have declared two variables. One of them is move speed, and the other one is turn speed. And those are again to easily change those numbers within the editor. Since they have serialized fields, they will appear in the editor, and their default values are given here and here. So inside update methods, let's talk about what is similar first. So in this case, I'm checking WASD. So D, when D is clicked, I am trying to transform my position. Set transform that position. Not set, but increase my transform that position by this amount. And I am taking into account this vector tree, which is the red axis of the transform in world space. So this gives us the, actually, let me play the game again. And I mean this transform.right always gives the positive red axis of the object. So it's always going to make me move to the right. So I should actually look at the world like this. So if I click this and if I go back to my game view, if I click D, it will go to the right um, relative to the object, you know. It will go in this direction since I'm using transform.right. We don't have transform.left, unfortunately, but we have minus transform.right, which is the same thing. So when I click A, I will be going to the left. If I click W key, I will go to forward, and I will uh, uh, transform.forward returns a normalized vector representing the blue axis of the transform in world space. So what is my blue axis? This is my blue axis. So I should be going like this. And if my object turns, this axis will be adjusted a bit. So now when I click W, it will go forward like this. Okay. And similarly, if I click backwards, when I turn, my negative um, forward methods, my negative forward vector will be taken into account. So I use minus transform.forward for that. And again, if I click space, I will teleport back to base. This is just for fun. So I'm going to click space now. And yeah, so my rotation is not changing, but my my position is changing. Okay. So let's go back to my scene. Okay, let's give a break if you don't have any more questions. And after the break, we will see how to move using rigid body. So there are again different control methods, and we will see another scene. See you. Let's meet after 15 minutes, shall we?
Okay, see you.
See you.